Okay, welcome back. In this app, we're going to look at the area model for the multiplication of the binomial ax plus b by cx plus d. And then we're going to go on and compare that with the algebraic model, and then in class we'll reinforce, we'll practice the algebraic model, which is by far the fastest way to do them. So here's the geometrical, sometimes called geometrical, or which is of course the area model. So I have it set up so that 2x plus 3 has been multiplied by 5x plus 4. So let's set up our grid here for the area. So we'll have 2x plus 3 being represented by these columns, and 5x plus 4, 5x being represented by this row, and 4 being represented by this row. And the 4 is of course going to multiply into these two terms, and so on. We'll take a look as we go. So let's start off with the 5x times 2x. So as always, we do sign, which is nothing really, plus plus. So next we go on to number, 5 2s is 10. Next we go on to variables, and the variables give us x times x, but we can shorten that to x squared. Okay. Moving on to 5x by 3. Well, I'd rather think about 3 times 5x. Actually, sorry, it's going to come down here. Do I have it now? So it's going to be 2x times 4, or 4 times 2x. Number by number is 8, and the x is just doing fine as he is. Okay, the x is great, doing fine, as I said. So next thing, we're going to have 5x times 3, which is 15x. And we're going to add him on here. Note that these are like terms now. And the next thing, we're going to have 4 3s is 12, which needs to get added on. Okay, so this is the unsimplified version. This is what arises naturally from the area model. And then we group the like terms in the yellow here to give us 15x here. Okay, ooh, got a bit of a glitch here in just how that. Oh no, yeah, that's giving that summary. And on we go to 10x squared plus 23x plus 12. Brilliant. Okay. Now, here's my algebraic model of the same thing. So here we have exact same setup. So the way we want to represent this early on is go first by first and last by last. As we saw already, these terms are not going to be grouped. And so what I like to do is not do any particular dynamic, any particular visual between them, as you're going to see in class. We just bring our fingers up here, or you make sure that you highlight, you think to yourself, I'm multiplying the 2x by the 5x, and go straight in for 10x squared into your question. The same with the 3 and the 4. We don't need any particular notation for it because it doesn't then need ongoing processing. Unlike the next bit of the step here, where we have the outers giving us 8x and the inners giving us 15x. Okay. As x terms, they need to be summed. So we sum the x terms, giving us 23x. Okay. And then summarizing, we have 10x squared plus the 23x, which was the sum of the cross products, plus 12. Just to link this back to what we were doing last week, we saw cross products when we were adding and subtracting fractions. We saw the two cross products in the numerator, but only a single simple term in the denominator. And that theme will follow us around throughout the entire course. One more thing to say is that we know this came about through multiplication, and so it wouldn't be unreasonable to think that we should be able to factorize it and get it to back out to look like the original product factors that multiply to give it. Okay, but just a note, exactly like numbers, where you have a like when you can have a composite number made up out of factors. For instance, 35 is a composite number and the factors are 5 and 7. You also have prime numbers, as we know, but you have prime quadratic trinomials. And when that happens, you can't factorize them, and you need a thing called a minus b formula, which we'll be talking about shortly. Okay, just finally, just another few things to say is I've this set up in such a way that we can change each of the x terms from 1 through to 6. and from 1 through to 6 in the second. Okay, and the constants can vary from -6 to +6. So for the various cases, we'll have plenty of fun, and we'll revisit this for various cases. But let's get the plus case sorted today. Thank you. Bye-bye. Didn't say goodbye, did I? Okay, bye now.